Good evening, everybody. Today we will discuss interesting Kaggle competition called CommonLit Evaluate Student Summaries. So this competition is related to natural language processing, and Ivan Glebov kindly agreed to make a talk on this competition. Thank you very much, Ivan, that you agreed to make a talk, and please start.
Hello, everyone. Thank you, Alexander. Today, how Alexander said, we are going to discuss about recently published Kaggle competition, CommonLit. What is the goal of this competition? We have table data with text, and the goal of competition is to graduate quality of summaries written by students in grades 3 to 12, and organization of who published this competition is very popular, I suppose, in Kaggle community, because last year these organizations were published known competition feedback, and in this competition I got not silver medal, brown medal, but if my teammate weren't slipped, we can won silver medal. But what about this competition? How I said before, the goal is quality of summaries, and in first C, we can think that it's a typical NLP competition where we have text column and where we have target. But first of all, target, it's not a class, it's two float volumes. So in machine learning definition, it's a competition about resolving multi-regression problem. But except what about target? Target, it's about quality. But what is quality? We have two targets named content and wording. And first of all, I don't understand at all what does this mean. And but we are going to speak about definition of content and wording a little bit later. So at this moment, we have two targets, two float targets, and how I said before, we have multi-regression problem. But except only text column, we have I'll see text column, which we have classify and predict, and except text column, which is exactly summaries. Yes, of essay. We have another text columns, prompt question and prompt title and prompt text. And this is interesting. This is interesting thing because in previous competitions we have only one. We had only one text column. So okay, here we are, text column, not classification task, but okay, regression task. And what we have to do first of all, of course, learn big transformers models. It's one opinion, but The goal of task is qualify a quality of summary, and before transformers, before neural nets, science community have different possibilities to qualify quality of text, and it's an interesting thing. Try to solve this task without learning big transformers, without learning big models. And I prepared a simple notebook where we don't learn big machine learning models, and we use only simple features, not exactly only simple features, but features about how to qualify text quality, like smoke index, tuning fog, text standard float, and other features from a great library TextStat. So we in this notebook we don't learn transformers, but also we can get not a bad results. So CV about 0.66, and this notebook got a result about public score about 0.55. Of course, if you are going to watch first stop of participants in leaderboard, you will see a much more lower results, but I suppose that these results will get using exactly learning machine learning models like transformers, and I suppose and I think that this is a result is very good for decision which doesn't have exactly learning transformer models. So this notebook is called No Transformers, but no so bad. And what is next step about this approach? How I said before, in this competition, we have except one text column. We have as a text column, but what is a problem? This text columns have a very rare unique values, exactly four, only four, and this is a problem. Next step which I wanted to use is to add features which use not only text column but have other which features which use other text columns except text. Here are simple text features, which means differs between, for example, amount of unique words between prompt text and unique words in original text which were written by a student. And just 5 features between other text columns. These features gave me a much more worse result than previous version, and it's an interesting thing, and we are going to take to talk about it later, but I suppose that meaning of this score is about, how I said before, very rare amount of unique values for prompt questions, prompt title, and prompt text. And exactly its amount about 4. Okay, next step which I did, I commented this features between prompt text and text, and added other features using transformers but without learning. I used cosine distance between text and prompt text, and also text and prompt questions. And these features gave me better results, like in cross-validation score and also in public score. And you can asked, why do you use this approach? Because you can just learn big transformer and get great score. Of course, I can do it, but I, like I suppose we are all know that in competition task, the best decision based on different approaches. And I think and I'm going to use this approach and combine this approach with traditional approach in resolving typical in NLP competition like this. Of course, I'm talking about learning transformer models. So, and also I have I think good notebook for learning transformer models. If you are going to see publish code kernels, you can find two approaches. Yes, one notebook for inference, for training your models, and second other notebook for inference your code. And of course, this notebook, this code has like a plus, like a minus. My notebook also includes also training and inference. And if you use this notebook, you can get pre-trained models, I'm sorry, fine-tuned models for this task. And also you will get score on public leaderboard. Except of this, you also can get except pre-trained models, you can get out of fault prediction for trained data set. And like I said before, it's typical NLP competition, and out-of-fault prediction for trained data set you can use in your future decision. I mean staking. It's a good approach for me. In this notebook, I use only one text column. I mean text. And other participants try to use other text column. prompt questions, prompt title, and prompt text. And how I saw, like in my experience, like in experience of other people, we all, I mean, almost all got worse result than only used only text, only original text column text, originally summary from essay. But I think that the clue of this competition, it's how to use other text column: prompt question, prompt title, and prompt text. Of course, we can use traditional technique in NLP competition, and we can combine all our text column by separate token. Yes, but first of all, first problem, prompt text has a much more words than text column, and it's obviously because it's task about how to qualify summaries, and summary of course has a much more lower amount of words than original text. But other problem, how I said before, is that in trained text we have a very rare amount of unique prompt questions and prompt title, prompt text. So I suppose that if we are going to use other text columns, our model can overfitting to generalized this several unique values of prompt questions, prompt title, and prompt text. So this typical approach for about combining all text column by separate token and push it to transformer models isn't working, unfortunately. But maybe we can find another approach. Yes, and also what else we can do in this competition, we can use different classification head. In this notebook, transformer prediction base, I used original approach from Hugging Face, using after model for sequence classification, but we can use different classification head, like in other NLP competition in Kaggle, like mean pooling, mean max, and attention head classification. But for me, this approach works better because unfortunately I can't use output of this notebook for combining in stacking, unfortunately for me, but I think you can do this work better. One of problem here is because like in previous notebook, I'm going to use Hugging Face trainer, and if we like to use a custom model and also using Hugging Face trainer, we have to modify our original model in PyTorch, and our model have to return except output of prediction like it's model also has to return loss. And here may be some problems to inference, and for me to save this model for reusing in staking, for using in staking. And what I also wanted to say that I think that its competition is very interesting because we have several text columns, but like I said before, this using these columns also has a big problem. Native approach can overfit your models, but I think that clue to win this competition, it's how to use different approach, and how to use this extra information. For me, I'm going to use not like a native approach using separate token, but build custom model, maybe which are going to use original text and other text columns, but second model which used text other text columns without learning, only with freeze gradient. Maybe this approach will get me more results. Sorry for my English. And but also, like I said before, this is typical NLP competition, and we can see that if you use classical modern approach with using big transformer models, it will get you good results. And also, like in other competitions, staking of birds is also working. But I hope that in this competition, using different approach will get the best results, and this behavior of using different approaches in finish will win, because I like different views to in solving competition like this. And at this moment, I am done. Thank you for all who are coming to our revision of CommonLit evaluate student summaries competition in Kaggle.
Ivan, thank you very much. Great talk. So now, colleagues, don't hesitate to ask questions. So now you can write a question in the chat, or you can unmute yourself and ask the questions by voice. So questions, comments, suggestions, everything is welcome, a kind of informal discussion. So don't hesitate, don't be shy. You're welcome to ask questions.
Yes, yes, yes. Welcome to ask questions if you like.
Okay, so let me maybe start with the questions, but colleagues don't hesitate. So about the first notebook where no transformers. So as far as I understand, you generated some set of features, but what was the motivation and ideas? These are some standard approaches, or what? Can you show it again, please? This one. What a number of unique words, number of sentences is up. Mean div automated what is the automated readability index? It's something from the package, or kind of.
Yes. Automated here's I use great Python library TextStat. TextStat has well-known things how to qualify quality and readability of text, and I think this library has a good features which you can use in this competition.
Okay, great. And so how many features? It's about 20 or 30, something like that.
Yeah, about less than 30.
And so the first model is trained on only these 30 features. Is it correct?
Yes. And this approach, using this approach, you can get result, get a score more than using small transformer models like dberta small and or x small dberta. So it's almost similar to learning small transformer models. And interesting thing that if we will see to cross-validation score, we will see that content score has a much more lower value than wording score. And if we will see to notebook with where I learn transformer models, we will see that content score has a almost similar value to content score to notebook which didn't use learning transformer models. But wording is more upper and is more greater. Wording and Messier transformer models, learning transformer models has a much lower score in wording, but almost similar in content. It's an interesting thing, and I think this approach can help you in combining with typical transformer models in blending or in staking.
Okay, thank you. Now, colleagues, don't hesitate to ask questions, comments, suggestions, whatever. You can write in the chat or ask by voice. You are welcome. So let me ask more questions. So, and the model which you use in this notebook is CatBoost, or?
Yes, CatBoost, because why I use CatBoost? Because CatBoost has a native multi-regression task, except XGBoost or LightGBM. Yes, you don't have to do multi-regression model. You just can put your features and your targets in your model and use multi-regression laws. And also CatBoost has his own approach for solving text features, and I'll send to him text features without any pre-processing, just like a name of column in my train data set.
Okay. And can you show, so how many targets or labels do we have, and can you maybe show them again?
We have 2 target columns, and our dataset amount of our dataset, it's about 7,000 samples. 7,000 samples, yes. And sorry for interrupting you, but I forgot about saying about cross-validation scheme. And and other participants in this competition, I used the group key fault validation scheme because like our organizations said that in private test we have a lot of different prompt questions and prompt titles than in train set. So using group key fault, you can simulate behavior in prediction test dataset.
Yes, thank you. And so both targets are regression, is it correct? And,
Yes.
And what is the metric organizers use to?
Metric of organizers used is mean column root mean square error. So we just calculate root mean square error and divide by amount of column by 2.
Okay, so there is 2 sums. The inner sum is by column and n and
in by targets and then in by column. Yes.
Okay. Okay. Thank you.
And also interesting thing that I don't know about CatBoost, but in learning neural network models, you also can use. Give me a second. Sorry, yes. Yes, but in if you decided to learn neural network models like transformers in regression task, we typically use multi-square error loss. Yes, but our competition have another metrics similar to MSE, but multi-column wise root mean square error. And during learning neural networks models, you also can use loss like a metric in competition. I haven't used, but other participants used. And that's interesting that they got a worse result when they used original loss slash metric from competition. Then typical approach like multi-square error loss. It's an interesting thing.
Okay, thank you very much. Colleagues, don't hesitate to ask questions. Antonino, Samuel, maybe you have questions or comments, suggestions. Maybe I'll ask more questions. So if you go to Transformers notebook, so your notebook, Transformers predictions is.
Yes, about these notebooks, not Transformers, but not so bad, and Transformers predictions base. It's not private. They are not private. They are public, and you and all other participants can use it. Can use their in their own. Their own winning things.
Is my understanding correct that you take the text description and put it into something like a sentence bird and get the embedding for the whole text, or it's not correct?
Not actually correct. Here two approaches. In first approach, not transformers, but not so bad. In first version, I didn't use any embeddings from transformers.
Yeah, okay, that I understand.
Yes.
About the other notebook.
Yes, in this notebook, I use sentence embedding from sentence transformers and calculate cosine distance between original text and student text and prompt text, and also cosine distance between text and prompt question, like a feature. One, not using all embeddings, because if I used all embedding from sentence transformers from text column, my model was overfitted. And here is I used only two values: cosine distance between text and between prompt text, and between text and between prompt question.
At some point you said that you kind of use this kind of Hugging Face models and use this transfer learning where you say additionally train these models for the particular task.
No, here is in this notebook, no transformers, but no so bad. I didn't learn transformers. I just use pre-trained models from Hugging Face, from centered transformers. I used two models. Well-known mini L to L12 V2 for paraphrase, and also QAMPNet. This model was trained in like a sentence transformers between questions and answers. And I saw that it's a good thing between, because in original data set we have a question and we have an answer text. So I saw that it will be good approach, use pre-trained sentence transformers models on data set similar to data set in our competition.
Okay, but I mean another notebook, transformers predictions. Can you maybe.
Transformer predictions. Yes, of course, transformer predictions. Here's a typical notebook when we just learn pre-trained transform models on our data set using only one text column, only text, which is summary, which is student summary.
Okay, so I'm not very familiar with this natural language processing environment. So can you please maybe comment a little bit on the code? So first we load some model.
Yes. Yes.
What model do you use?
Yes, here is I using config class where we declare model name and all other hyperparameters, yes, which we are going to use in education. So if you like to get new model or change something, this is the only one cell which you have to change. For example, change if you change the name of model, you will train as a model. For example, BERT, or for example, DBERT V3 large. Yes, and lower other hyperparameters, learning rate, and num train epochs, fade decay, and other things.
Okay.
And lower just code which use Hugging Face trainer. I didn't write my own code for education with forward step, backward step, yes, with compute loss. I just used only Hugging Face trainer class. Here's trainer arguments. And here is declaration of trainer class, of Hugging Face trainer class. And then we just write one row, train, and we will get a trained model. I used also safe strategy steps. So at the final step, we will save the best model during education. And this code, train and info, will run 4 times because I use, how I said before, group key fault cross-validation strategy. And I'll run this code for 4 times for every 3 different groups in our data set, different groups of prompt ID. And like in output, you will get like a pre-trained models, and also out of fault prediction for trained data set, and also you will get a result in public leaderboard.
Okay, thank you. Have you looked how leaderboard score and your local CV score fit each other? I mean, is there kind of...
Oh, sorry, I'm not going. Sorry for you. I'm not going to see our my correlation between CV score and public score, but I can say that the correlation between cross-validation score and public score exists, but if your cross-validation scores changed a little, it will not means a little in best manner. Yes, it will not means that your public score also will decrease in the same manner.
Okay.
But if your cross-validation score will decrease, for example, by 1%, yes, and this means that your public score will decrease also.
Okay, okay, thank you.
I think it means because public data set has I can find, but I saw that public data set has only 13% of all test data set, and it's like another fault. And other guys in discussion in forum thought that public data set has only one or two different prompt title. And also I thought that you, for example, can overfit your model on some prompt from your trained data set, and you will get good public score, but obviously not good private score in future. And Ruda asked me, can you show please a code where you transform make sentence bearing? Yes, I used in notebook, not transformers, but not so bad in third version. Here I declared a model, two models for getting sentence embedding, and one model from previous competition. And I used you can use sentence in transformers library, but I use natively Hugging Face model, and I used a function mean padding for pulling for using for getting embeddings only which have attention mask equal 1, and and also I got normalized embeddings. Yes, and to get cosine distance, because I have normalized embeddings, I can use only multiplication and sum for getting cosine distance without dividing to norm of embedding vectors.
Okay, thank you very much. Also, you mentioned something about stacking BERTs. What is it?
Yes. Stacking is a typical approach for
yeah, I know what is stacking, but I mean, in this context for BERTs,
yes. Sorry guys, I'm not going to show my notebook about stacking BERTs, but like I said before, for using staking, you have to have prediction of your models in out of fault manner. Yes, and this notebook, my public notebook, Transformers prediction based, like I said before, in output you will get except pre-trained models, also out of fault predictions for trained data set, which you can use for staking your models. So for example, you can use this notebook, just write this one name model, then write another model, and build a data set from output of your notebooks, combine them, and use it, the outputs for building staking model.
So you mean we use different birth models as different models for the
Different, yes,
different kind of
yes, different.
Okay.
Actually, staking is tricky thing. You can different transformer models, but also you can use same models but with different hyperparameters. What approach will be better? Who knows? We have to try.
Okay. And so how far is now top kind of top solutions on the leaderboard from the, for example, your notebook or other public notebooks?
Oh yes, unfortunately it's far, because in this notebook I only used DBERT base model, and other public notebooks started use DBERT large models, and like I said, bigger models will get you better results in general. And I only used at this moment only DBERT base model, but I'm going to use bigger models like DBERT large or DBERT X large. The best published notebook has score 0.482, and my solution is 0.485. Best solution is about 0.44, and and I know that if you are going to learn in accurate manner bigger models, you will get better results.
Okay, thank you. And so as far as I understand, this competition is somewhat similar to the previous one from the same organization. Yes.
Yes, but the differences between previous competitions, that previous competition was submit competition, not code competition, and in previous competition you can do much more easier staking, blending, and other typical for Kaggle competitions things. But this competition is a code competition, and you have troubles, and you have you have to have skills to do blending in stacking and stacking. But interesting thing, in one of version of my notebook, no transformers, but not so bad, I used a model from previous competition to calculate target from previous competitions. Yes, and used it like a features, and it also got me a good results. So this is one approach which you can use in this competition. For example, use a pre-trained model from previous competition.
Okay, thank you very much.
But in previous competition, we also had to qualify text quality. Yes, but students were from 8th grade to 12th. But in this competition, students from 3 to 12 graduate.
Okay.
Different things, different levels.
Okay. But in general, in the previous competition, so when a competition finished, people typically show their solutions. So have you looked at what are the kind of ideas in the previous competition? All of them were something like this, which you say, we do some birds and stacking, or there was something alternative?
I can say that I saw all solutions from previous competitions, but most of all used stacking of BERT, like I said before. But also, like I said, previous competitions was submit competitions, and some participants used the technique like pseudo labeling. And in this competition, you can't use pseudo labeling because you don't have test data set. And it's good for me because I don't like using technique like pseudo labeling. And interesting that one of tops solutions for previous competitions actually didn't use staking, but just tricky blending of output of their models without education second level staking, but just only blending, but with tricky things.
Okay, thank you very much. So colleagues, don't hesitate to ask questions, comments, suggestions, whatever. Just a small question. So this notebook with transformers, so how much time do you run it? It's something like 5,000 seconds or?
Yeah.
On GPU?
Yes, on GPU. This time because in this notebook you have train and inference in the same notebook. Unfortunately, you have to train your model twice time. Yes, because in first run you will train and infer on a small data set, and after this, if your run was successful, you have to rerun your model and rerun training on and inference on all data set, on all test data set, and this time much bigger than approach when you use two different notebooks with train and infer, because you have to train your model twice. But you will get a result score from running only one notebook.
Okay, okay, thank you very much. Okay, colleagues, any other questions, suggestions, comments?
Sorry, Ivan, do you hear me?
Yes.
Yes, yes, I hear you, Luda.
Hi. Can you explain if we have embedding as input and embedding as output, and if output embedding is your sentence transformers output, which size of this embedding?
Uh-huh.
How long is sentence embedding?
Okay. Okay, yeah, I use sentence transformers named mini L12, L12 V2, and actually, sentence transformers has a much more popular model, which has embedding output size 386. But in this version of my notebook, I used more bigger model, which has embeddings output embedding size typical for transformer models. You say me, 784. Yes, 784, I suppose.
Okay, and if we have embedding as input and embedding as output, what is between them? How input become output?
Okay. Actually, in texts, we don't have embedding like input. We have several embeddings like input after embedding layer. For example, typical transform models has sequence max length 512. So input size of your model, it's batch size 512 and embedding size like 784. But for classification, we have to have an output from your model in a strict form, like batch size, embedding size. So we have to use pooling form, yes, pooling types. And for sentence transformers, typically we use mean pooling. It's a mean of all output embeddings from your model. Not actually all, only embeddings which has attention mask equal 1. So we just combine and divide by equal embeddings from last layer of transformer models.
Oh, sorry, repeat please last two process. When you using output embedding, like target, like maybe not about this model, but if we have abstract one embedding as input, maybe 100, and one embedding as output, maybe same 100, but other different at all position. How we can make one from others? How I say?
Okay. Like I said before, the model input of model isn't one embedding. Yes, it's several embedding for each token. So input of model is input size of model is batch size, max length, and embedding size, and it's a first input of first layer from transformer models, and output size from transformer models. It's also the same size, batch size, max length, and embedding size. But for classification, we have to do to get strict size, and we have typically two different approach: mean pooling, just combine all embeddings from last layer and divide by their amount, or CLS pooling. It's a special embedding from for token. From first token in the sentence, which we added to original sentence. And in an approach like this, we can get a strict embedding from with size, with strict size from any transform models. Is your question about it? Whole other thing? So we okay, we have for example, for text and prompt text, we calculate one sentence embedding using mean pooling for text. Yes, and one sentence embedding for all text for prompt text. And our embeddings are normalized because we use this function. And for calculating cosine score, we just can multiply our embeddings and sum the result of multiplications, and we will get cosine distance. Actually, cosine of between two vectors.
Okay, maybe fun question. Can transformer only make embedding from text or something more difficult? No.
Yeah. You can use for getting embeddings from text. Yes, using transformers for getting embedding. But like I said before, if I added embedding from text using transformers to my original features, my original simple features, I will get a result much more worse. Yes, much more bigger than in native approach. And this is a problem in this competition because I think that a model can overfit because in trained data set we have 7,000 samples, but amount of embeddings, size of embedding from transformers, it's in range from 300 to 700. So finish amount of your features can be similar to amount samples in your trained data set, and it can be a problem, and it can be or it can overfit your model.
Sorry, and explain how you make more easier model and don't overfit. Explain. You say this before, but repeat, please.
Oh, okay. I just did not use transform embeddings in this notebook because if I am going to use, if I okay, here is I only have a cosine distance between embeddings, but not exactly embedding from text. This size of these features is 1. If I'm going to use embedding text, embedding vector from text, my final amount of features will about 700. It's a lot of features. And if you have a lot of features with not a big data set, trained data set like own, because our data set has only about 7,000 samples. Yes, you can overfit your model, but here's a tricky. Yes, because actually I use text column, but like a feature of cut boost without getting embedded, embedding from transformer models. But you can try use this notebook and add 2 features embedding from text. Maybe I did not use this approach correctly, and maybe you will get much more better results.
Okay, and how long it take of your time to make sentence embedding and to calculate cosine similarity?
Yes, it will take a long time. Actually, I have to say that these features from text stat library also has a big amount of time to calculate features. This is simple features, but they calculated long time. And in this notebook, third version, where I use embeddings, it will take it took about 2 hours, but in this notebook I didn't use GPU. So you can use GPU to calculate embeddings, sentence embeddings, and your run will be faster 2 times, I suppose. Just add GPU and your life will be better.
Maybe
I wanted to add GPU to my wife. Maybe she will be better. I'm joking.
okay. And to child too?
No, child is good. I'm
Okay.
joking. I'm joking. Of course, I love my wife.
But GPU left more, yes.
Yes.
Your plan to future to this competition?
Yes, my plans is simple. I'm going to improve both approaches, add features to notebook, no transformers, but not so bad, maybe features from previous competitions, and improve models, several models from notebook transformers predictions base and use larger models, and then combine outputs from all approaches in one notebook and use stacking techniques. But for me, it's difficult to use custom at this moment to use custom models with different classification head, because I'll get different results when I run this notebook, yes, and get a public score after running, and then in using outputs in staking scheme in staking notebook. So I have to decide several problems how to correctly save models with custom classification head and how then load. And also I want to try different neural network architectures in which I can use like a text and prompt question and prompt title and prompt text. But how, like I said before, this this approach can fit your model, but I'm going to try to use different neural network architectures, custom architectures.
Idea of this architecture, why you think you can use this?
I haven't got.
I think you have idea your architecture do not overfit. You have some way to how it look. What architecture it will be?
I'm going to tell you at this moment. I think that I have a brilliant ideas, some brilliant ideas, but not for big community. If my ideas will not so brilliant like I think, I will share notebooks. But okay, a simple answer is I'm not going to use a model. I'm going to use model with freeze gradient for prompt questions and prompt title and prompt text. Because I think that this approach will not overfit for several unique values in text columns.
And can we look through some public notebook? I think maybe I hear it's some public notebook with many complex things. Can we look through all public notebooks?
Yeah, no, okay, yes, no, Transformers, but not so bad is public notebook, and Transformers prediction backed base is also public notebook.
Is it some other public notebook with some different thing that you?
Different
yes.
things.
What you?
Yes, you have a best. You will see best public notebook at this moment with custom classification head. Yes, and also, and this notebook has the best result, but notebook with classic approach, yes, where you build features and this competition, you can find several notebooks, but with much more worse results. With much more, about 600 or 1,000 about this. Yes, and like I said, in the finish of this notebook, the main idea of this notebook inspire community not only train transformers but to find new interesting solutions. So you can inspire of this notebook and find other solutions.
And things that you can make and I can't. How you download a model from Hugging Face?
Oh, it's an interesting approach. So I create a notebook with internet, and in this notebook I just use a typical code for loading Hugging Face model, like a URL from Hugging Face, yes, and save output. And so in this notebook I downloaded model from Hugging Face, save again model and tokenizer, and just run this notebook, and this notebook will have output with downloaded model from Hugging Face. And output from notebook you can use, you can transform to data set, which you can use in all Kaggle competitions, because you have a data set.
And all files like some XML files or config files is built when you load model from Hugging Face. In your folder,
Yes.
every model has not one file. Can you look to some model or to some model maybe in this notebook where in dataset maybe some. It's not one. No.
Yes. Yes.
Up. Go to up to look to data source for this notebook.
Data source or output?
No, only a source when you connect.
Yes. Well, for example, dberta v3
Okay,
base.
yes. And it's not one file in folder, but some other files. What it mean?
Yes, here's several files. PyTorch underscore model bin is the main file of weights of model. And also you have a configuration file config.son, which has information about name of model, layers, size of intermediate layers, and other things, or how to build your model from config. And also you in this folder you has all needed files to your tokenization model. Tokenizer config, and in dberta we have slow tokenizer, and we don't have vocab txt. We have SPM model, which exactly you can explain this like tokenized model. So for Hugging Face model, we have that in one folder should be weight file with weights for neural networks, file with config, and all files needed for tokenizer. Oh, yes, here's vocab type is PM. Other models can have vocab .txt file, for example, and files like additional tokens .json. So in general, 3 parts: model weights, configuration file for model, and files for tokenizator.
Thank you.
You are welcome.
Thank you very much. So,
Sorry guys, I'm glad to see you and hear you, but it was a interesting meeting, but family things, I have to go, unfortunately.
okay, but thank you very much. It was great talk. Thank you very much for sharing the ideas. So let me now stop recording, and video record will be available on the YouTube channel, I hope, tomorrow.